Welcome to Learn with Roblox. In today's video, we're going to talk about this formula. So the formula we're going to talk about is 1/2 times A times B times the sine of C. And what does this give us? It gives you the area of a triangle. So let me just draw a triangle and explain to you what A, B, and C are. So if we draw just any triangle, this doesn't have to be a right triangle or a special triangle. You can use it with any triangle you want. Let's say this side is A. Let's say this side is B, and this is the most important part. C has to be the angle in between A and B. So let this angle be called C. So if you do 1/2 times the side length of A times the side length of B times the sine of angle C, you will get the area of this whole triangle. So that's what this formula is all about. Let's take a look at a few problems to explain this concept better. So in this first problem, we need to find the area of this triangle. We're given that one side length is 3, the other side length is 7, and the angle between them is 41 degrees. So let's call the formula that we just learned. We have 1/2 A, B, sine C, and this will give us the formula. All we need to do is plug in the right numbers and then solve. So let me just erase all of this and put in the right numbers. So you have 1/2 again, that's a constant. Our first side length is 3, or you could write it as 7, that's fine. And then the other side length is 7, or if you chose 7 first, it would be 3. And then we need to multiply this by the sine of 41 degrees. And then if you do all that on a calculator, what you should get is that this area is equal to 6.88. That's it. That's how simple it is to use this formula. Let's see a few more problems just like this to reinforce this concept. In this problem, you have a triangle with side lengths of 10, 13, and an angle between them of 21 degrees. Let's recall the formula that will help us find the area of this triangle. So remember, that magic formula is 1/2 A, B times the sine of C, where C is our angle. So let me be more clear than it was in the first problem. I'll label A, B, and C directly on this triangle. So A is one of the side lengths. I'll just leave this as A. That means the other side is B. And the angle between them is C. So this is what we're going to plug in. So let me plug in those numbers right now. So you have 1/2 times 10, because that's A. B is 13. And then the sine of 21. And now you just need to compute this on a calculator. So take out a calculator and do 1/2 times 10 times 13 times sine of 21. Make sure your calculator is in degrees and not radians. And then that'll get you the answer. And if you do all that, you should get that the answer is about 23.29. So that is the area of this triangle, and we're done. Let's find the area of this triangle with side lengths of 6, 7, and an angle of 119 between them. So the formula we need is 1/2 AB sine C. As always, where A and B are the side lengths, so I'll call 6 as A, and I'll call 7 B, and 119 degrees is just C. Let me just plug in those numbers into this formula and solve for the area of this triangle. So 1/2 times 6 times 7 times sine of 119 degrees. Put that into a calculator, and what you should get is 18.37. And that's it. That's the area of this triangle. This problem has a different setup than the past ones we've seen. So here we have a triangle with side lengths of 15 and x and an angle between them of 72. And we're also given that the area is 28. Based on that, let's try and solve for x. So what's the formula we're going to use? It's the same one as in the previous problems. So 1/2 A, B, sine C is equal to the area of this triangle. And what do you know about the area? We know it's 28, so let me put that in. And then we also know A, B, and C. A is 15, or you can call that B if you want, but it doesn't matter. B is x, and C is 72 degrees. So let me just fill in all those variables. It's going to rewrite all of this actually. So we have 1/2 times 15 times x times sine of 72 degrees. And now we just need to solve for x. So first I'm going to do 1/2 times 15 times sine of 72 to get the new coefficient on x. So if you do all of that, what you should get is that 7.13 x is equal to 28. And now to solve for x, you just divide by 7.13. And if you do all that math, you should get that x is equal to 3.93. So the missing side length was just 3.93. Let me fill that in on this triangle just to be complete. So now we have 3.93 is this side length. So in this problem, we have a triangle with side lengths of x and x, so it's an isosceles triangle, and an angle between them of 39 degrees. And we know that the area of this triangle is 100. Based on that, we need to solve for x. So let's get the formula that we've always used. That formula is 1/2 AB sine C is equal to the area, which we know is 100 in this case. And now we know A and B are just x now, since those are the side lengths, and C is our angle, which is 39 degrees. So let me just fill in everything here. We have 1/2 x times sine of 39 degrees. X times x is just x squared. So I can say this is just 1/2 x squared. And then now what I'm going to do is I'm going to multiply 1/2 and sine of 39. So I know what the right coefficient is for x squared. So 1/2 times sine of 39, if you do that, you should get a coefficient of 0.315. And that's the coefficient of x squared. From here, all you need to do is just divide by 0.315 to eliminate that coefficient and isolate x squared so you can solve for it. So now, if you do 100 divided by 0.315, you should get that x squared is equal to 317.5. And then now, to solve for x, just take a square root. So the square and the square will cancel. And if you do that on a calculator, you should get that x is simply equal to 17.82. So that is our answer. So I can fill that in on this triangle now. So both of these sides are 17.82. And we're done. In our final problem of the day, we have a triangle with side lengths of 9 and 10, and the angle between them is x degrees. And we need to find what x degrees is based on the fact that the area of this triangle is 16.13. So this problem is actually a bit trickier than you think. It actually has two answers, and I'll show you why that's the case, but let's just see how to solve this problem. To solve this problem, what I would do is plug the formula 1/2 AB sine C is equal to the area of a triangle, which in this case is just 16.13. And now let's label A, B, and C. A is one side, B is the other side, and C is the angle. So let me just rewrite this in terms of what we know. We have 1/2 times 9 times 10 times the sine of x degrees is equal to 16.13. Next, let's do 1/2 times 9 times 10 just to clean this up a bit. So if you do 1/2 times 9 times 10, you should get 45. And then let's isolate sine x. To isolate sine x, just divide by 45 because that's the coefficient. And now, if you do that, you should get that sine of x is equal to 0.358. So now, how do you solve for x? Well, whenever you have sine of x equals some number, what you need to do is apply the inverse sine function. So let me rewrite this actually because I need some space to do it. So apply this function, sine minus 1, that's called inverse sine, onto this sine of x. And then apply that sine inverse sine function onto the other side. So we had 0.358 on the other side. So now the sine inverse and the sine cancel out just to leave us x. And then now you just need to compute inverse sine of 0.358. So go to your calculator, take the inverse sine of 0.358. And if you do that, you should get an angle. And the angle you should get is 21 degrees. So this is one solution to our problem. So x could be 21 degrees. But how in the world can there be a different solution? Let me explain to you why there's a different solution. So we know that sine 21 is equal to 0.358. How do I know that? Well, when we did the inverse sine of 0.358, that just spits out an angle for us. And this tells us that sine of 21 equals 0.358. That's the relation between sine and inverse sine. But let me tell you something. There's actually another angle where if you take the sine of it, you also get 0.358. So to do this, I'm going to have to reference a little bit of pre-calculus. So if you aren't familiar with the unit circle, this part might not make a bit of sense to you, but I'll explain it as best as I can. But you might need a bit of pre-calculus to understand this. So on a unit circle, remember that whenever we have an angle on the unit circle, so this time I'd have 21 degrees. Whenever you take the sine out of an angle on a unit circle, all it's telling you it is, if I have this point here at 21 degrees, the sine just tells you how tall it is. So all this is saying that if you have the unit circle at this point that is 21 degrees from the origin, it is 0.358 units tall. But there's another place on the unit circle where sine is equal to 0.358. It's all the way over here, right across the y-axis. So here, if you measure the height of this point, that is reflected across the y-axis, it is also 0.358. So there's actually another angle. It's this big angle over here that's an alternate solution to our problem. And how do I get what this big angle should be? Well, think about it. If I just reflected this angle across the y-axis, I know that this little bit here is 21 degrees. And then I know that this whole thing is 180 degrees. So therefore, if this is 180 and this is 21, I just need to do 180 minus 21 to get the alternate angle. So 180 minus 21. And that means the other angle that could be the solution is 159 degrees. And there are actually two solutions to this problem. So let me go back and actually try and draw both triangles that could have occurred. So I'm just going to erase all this here. So in one triangle, we'd have 9, 10, and 21 degrees. And in the other triangle, we're going to have 9, and then 10, and then we'll have an angle that's actually 159 degrees. So these triangles actually have the same exact area, even though they have a different angle. And the reason that's the case is because if you take the sine of 21 and the sine of 159 degrees, they're the exact same value. So our problem actually has two solutions. If you enjoyed this video, please like and subscribe. Thank you for watching.